Alright, here we go. Welcome back to Geometry. We're in Chapter 4, Section 5, talking about dilations today. Okay, if you look at this image right here, we're looking at a dilation. A dilation is an enlargement or a reduction about a point C. So here we have C, and that's called the center of dilation. And from that point, so here's our original image, we have a dilation, in this case, an enlargement. Okay, and then we have, if we enlarge that, we enlarge it by a scale factor of k. Now k is found by taking the distance from C to the new point, P prime. So this new distance over the original distance. That is our scale factor. So, for example, just an easy example, if this distance right here was 2, and the distance from C to P was 1, then our scale factor would be 2 over 1, new to original. We could also write that K is C to P prime over C to P. Now, if our center point of the dilation is point P, if C equals P, then P prime equals P. Alright, if this is in a coordinate grid, if we have a dilation centered at the origin, so C would be here, then we can find our new coordinates just by multiplying each coordinate by the scale factor. So we would multiply x by the scale factor k and multiply y by the scale factor k. Multiply x and y by the scale factor. Alright, so let's try that. Here's how I would set this up. If we have, here's a triangle, and we're given the coordinates, I would write those coordinates out. Now we're supposed to graph both the triangle and its image after dilation. So 2 and 1, there's A. E is 4 and 1. B, C is 4 and negative 1. So there's our original. There we go. Alright, and now we want to make a dilation with a scale factor of 2. Now 2 is 2 over 1. So I'm going to multiply each of these by 2. So all of these times 2. 2 times 2 is 4. 1 times 2 is 2. So A prime is at 4 and 2. B prime is at 8 and 2. C prime is at 8 and negative 2. Alright, so 4 and 2. Let's change colors here. 4 and 2. A prime. That's weird. A prime. There we go. 8 and 2. 8 and 2. There is B prime. And C prime, 8 and negative 2. Okay, if you can see here, right, that's on the line right there. These 2 points are on one line, and the C's are on one line. So C. There's our dilation. Okay, now we have a scale factor of 1/3. So again, we're going to multiply all of this times 1/3. Multiplying by a fraction is the same as dividing by its reciprocal. So multiplying by 1/3 is the same as dividing by 3. So this gives me k prime of negative 1 and 2. 0 times 1/3 gives me 0. 6 times 1/3, or divided by 3, gives me 2. M prime gives me 1 and 1. And n prime is negative 1 and negative 1. All right, so let's draw our original. Okay, so there's our original shape, and then our new shape. K is at negative 1 and 2. K prime. L is at 0 and 2. L prime, 1 and 1. This is M prime, and then negative 1 and 1. N prime. There we go. There's a dilation by a fraction. Notice it got smaller in this case. Slopes are still the same. Now we've got by a negative fraction our scale factors, so we're going to multiply all of these by negative 1/2. That gives me f prime of, these are both going to be positive, times a half means dividing by 2, so positive 2 and 1. G prime is positive 1, and this becomes negative 2. And then H prime, these are each going to be positive 1 and 1. Draw my original shape. F is negative 4 and negative 2. So there's our original shape, and then 2 and 1. There's F prime. G prime is 1 and negative 2. G prime, and then H is 1 and 1. There's H prime. And notice that our shape flipped upside down in the dilation. So it's half as big, but it flipped upside down. All right. Making your own photo stickers. Your photo is 4x4. The image on the stickers is 1.5 by 1.1 by 1.1. What's the scale factor of the dilation? Remember, scale factor is new to original. So this is pretty easy. The new is 1.1. The scale factor is 4. So we can expand this and change that, take the decimal out. If we move it over here, move it over there, we get 11/40. All right, there's our scale factor. Since we don't want the decimals in the fraction. Boom. All right, you're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. Determine the length of the image of the spider seen through the magnifying glass. Okay, so I told you the scale factor is new to original. Scale factor is new to original. Now, in this case, you could call that the image, which is the new, and to the actual. Okay, so the actual spider is 1.5 centimeters, and we want to know what is it after magnification. Okay, now we know that the magnification is 6 times, so 6 is equal to x over 1.5. Multiply each side by 1.5. And we get a grand total of 9. So the spider is now 9 centimeters if seen through the magnifying glass. It appears to be 9 centimeters large. I'm not sure how we missed this example, but we'll just go ahead and throw it in. Find the scale factor of the dilation and tell whether it's a reduction or enlargement. All right, so here's P. That means this is the original, this is the new. So obviously it got bigger, so this is an enlargement. Enlargement. And the scale factor is C to P prime, so 12. K is 12 over the original distance is 8. Simplify that. Always simplify your fractions. That's 6 over 4. Can still be simplified to 3 over 2. So the scale factor is 3 over 2. B, this is a reduction. All right, this is the original right here. Here's P prime. Now the scale factor, remember, K is new to original. And that is the new distance is the 18. So 18 over 30, and that can be simplified down to 9/15, which can be simplified down to 3/5. And there you go. There you have it, dilations. Remember, our scale factor is new to original. See you next time.